Hello and welcome everyone. This is Alok and welcome back to another video of the linked list series. In this video, we'll be learning how to reverse a linked list. If you remember, in the previous video, we printed the linked list in reverse order without actually reversing it. But today, we'll be going one step further in this concept and we'll be actually reversing this entire linked list and printing it. Right? Hope you all must be doing great. Let's get started with our work. So this is the name of our topic. So basically we'll be having a linked list and we'll be reversing it. Let me show you an example. In this example, we are having a linked list in which 10 is pointing towards 20, 20 is pointing towards 30, 30 is pointing towards 40, and 40 is ultimately pointing towards null. And after reversing it, it should look like this. Exactly opposite of it. We are having the head node with a value 40 and 10 is pointing towards null. So we have reversed the linked list. Let's move further. So there are two ways to perform this operation. In this video, we'll be covering the easier way, that is the iteration way. Over here, I have marked it with white, and for the recursive technique, we'll be covering it in some another video. So let's get started with our work. But before coding it, we'll be first understanding the algorithm of it, and after that, we'll be coding it. So let's move on to my coding network. So this is my coding network. It's a website where I frequently upload articles related to coding. So over here, I am having an article, reverse a linked list. In this article, I have discussed how to reverse a linked list. The algorithm for reversing the linked list iteratively. So there are several steps involved. First of all, I'll be creating three nodes as previous, current, and next. I have used the shorthand notation of previous and current. This is going to be the first step. We'll first be creating three nodes. In the next step, we need to assign these nodes as following: previous as null, next as null, and current would be assigned with the head node. This step is followed by creating a while loop with a condition current is not equal to head. Means the loop will terminate, the while loop will terminate when current is not equal to null. Right. These are the four operations that would be happening inside the while loop iteratively. First of all, next is assigned with a node which is next to current node, right? The second step is the main operation inside this while loop where current is made to point towards previous. It means we are reversing the direction in which it is pointing. And the last two steps are basically assigning operations where previous is assigned with current node and the current node is assigned with next. Prepare this entire loop for the next iteration. But when the condition reaches current equal to null, the loop terminates. And after the while loop terminates, the previous node would be containing the head of the linked list, right? And we would be returning the previous node. This is the source code of the reverse function that we would be coding. And after reversing of the linked list, this was our original linked list, and after applying the reverse operation, this linked list would look like this. I've also added handwritten explanation of what is happening inside this reverse function. You can check out this article. I will provide the link of this article in the description. So let's start coding it. So this is the linked list that I've already created. Here we are having values 10, 20 till 60, and 60 is ultimately pointing towards null. Let's run the code first to know the current structure of the linked list, and then we'll write the reverse function to reverse it, and then we'll traverse it to see the reverse linked list. Okay, this is the current structure of our linked list, 10 to 60, and 60 is the value of the last node. So the last node is pointing towards null. Let's now write the reverse function. First of all, I'll be writing the function definition. It will take node head as the parameter. First of all, we'll be creating a base condition. If the parameter head is equal to null, or if head is pointing towards null, then it should return. It should return head of the linked list. Let's perform the algorithm that we have just discussed. First of all, we'll be creating three nodes. This was our first step, defining three nodes. Let's now create the while loop. And the while loop, if you remember, there were four operations. The first operation was next is assigned with cur.next. Now this is the main step. Cur.next equals to previous. So basically we are making the current node point towards previous. This is where actual reversing is performed. And the last two operations are assigning operations, where previous is assigned with current node. We are using the shorthand notation, remember. So this was our while loop. Let's move on further. After the while loop terminates, the previous node would be having the head of the reverse linked list, the new reverse linked list that we have created. So now we'll be returning that previous node. So we have successfully created the reverse function. Let's now call it from the main function so that we can use it. Below this traverse function call statement, we'll be performing our reversing operation. So now let's do it. I'm typing this comment and the printing statement for your understanding. Let's now call the reverse function, and the value returned by this reverse function will be storing it in the head of the current linked list, means the unreversed linked list. So now till this step, our linked list is reversed. Now we'll be traversing that linked list. So this was our entire code. First we had written the reverse function. Let's now check it how the code runs. So as you can see, it is running perfectly. First we had printed original linked list, and after reversing, our linked list is looking like this. So we have successfully executed the code. Hope you guys must have enjoyed the video. So let's meet in the next video. Till then, goodbye.